All right, in this video we are going to talk about cycloalkanes. So it's basically just an extension of the alkanes. It's just a more specific group. So as it says, we're going to talk about the nomenclature of cycloalkanes and then drawing their skeletal structures. So cycloalkanes basically are alkanes, and the carbon atoms of the alkane are arranged in a ring. So if we were talking about our general molecular formula, let's just talk about a very simple one. Let's talk about propane. So propane is normally CnH2n plus 2, as we talked about on the first page of these notes. So we talked about each carbon having 2 hydrogens, and then the end carbons, no matter if your chain is 10 or 3, always have a hydrogen to cap it off. So that's what this plus 2 is for the caps on it. When we form a ring, it doesn't matter how many atoms are in our ring, we're going to basically remove 2 hydrogens and connect the ends together. So our general molecular formula is CnH2n. As it says, we're going to name them by adding the prefix cyclo to the alkane to signify those carbons are in a ring. So as you look at this first one, there's 1, 2, 3 carbons in the ring. 1, 2, 3. So with 3 carbons, we call it propane. To indicate they're in a ring, we call it cyclopropane. The next one, we see 1, 2, 3, 4 carbons. So 4 is cyclobutane. The next one, we see 1, 2, 3, 4, 5. So this is cyclopentane. And the last one, we see 1, 2, 3, 4, 5, 6. So this is Cyclo Hexane. So we are going to basically incorporate all of the stuff we've already talked about and add this in. So as it says, in a cycloalkane with an attached substituent, the ring is your parent chain unless the substituent has more carbons than the ring. So for example, this ring is 5, the substituent is 1. So the longest chain we have is 5. Over here, our ring is 4, and the chain is 1, 2, 3, 4, 5. So this becomes the parent. So the substituent is the parent chain if it's longer than the ring. There's no need to number the position of a single group attached to a ring because no matter where you put it, it always gives you the same name. And if the substituent is a cycloalkane name, the prefix cyclo is not ignored. So now, to make your life more complicated, we're going to not ignore iso, and we are not going to ignore cyclo. So in this first group, we see our parent chain. The longest continuous chain is going to be the ring. So our ring is 5 here, and we have a methyl coming off of it. It's not wrong to say 1-methyl cyclopentane, but you really don't need the 1 because there's no other place it could be. If you say methyl cyclopentane, you would be able to draw the exact same structure. The next one, our parent chain is going to be the 6 in the ring, and so this 2 coming off is our substituent, so we call it ethyl cyclohexane. And as we said, you could put a 1 out in front of it, but you don't need to. And the last one in this example, 4 is the ring, so that's its own like standalone unit, and this is 1, 2, 3, 4, 5. So our parent chain is actually going to be this, and the cyclobutane is going to be a substituent. So we want to give a substituent our lowest possible number. So we're going to number our parent chain in the direction that gives it the lowest number. And we'll call it 1-cyclobutyl. And our parent chain in this case is pentane. As it says, if the ring has 2 different substituents, we list them in alphabetical order, and 1 is given to the substituent listed first. So in this first case, our parent chain is cyclopentane. We have a methyl here, and we have a propyl here. So we're going to give the 1 position to methyl and 2 to propyl based on alphabetical. So 1 methyl, 2 propyl, then we list our parent, which is cyclopentane. The next one, our parent chain is also cyclopentane. We have a methyl group here. We have 2 carbons down here, so this is ethyl. Alphabetically, E comes first, so this is going to be 1. The lowest number we can give to methyl is 3. So as you notice, it's not 4-methyl, it's 3-methyl, because we want to give it the lowest number. And then we cite them all alphabetically. So 1-ethyl, 3-methyl, cyclopentane. The next one, our parent chain is hexane. We have 2 methyl groups, so 1 here and 1 here. The lowest numbers we can give them are 1, 2, and 3. So we're going to be 1,3 dimethyl, and then cite the parent, cyclohexane. The last rule is if there's more than 2 substituents on the ring, they're still listed in alphabetical order, and the 1 goes basically to the substituent that gives everything else the lowest number. So for example, in this case, our parent chain is cyclopentane. So we could either call this number 1, this group could be 1, or these groups could be 1. So we want to give everything the lowest possible number. So we're going to say this is number 1 and this is number 2. So in this case, we're going to have 1, 1, 2, trimethyl cyclopentane. So just to be clear, if there's 2 substituents on the ring, they are determined alphabetically. And as we said, basically we want to give the 1 position goes to whichever one comes alphabetically first. If there's 3 substituents, the first priority is giving everyone the lowest possible number. So in this next case, our parent chain is 6, cyclohexane. If we start numbering here, we go 1, 2, and 4 as our substituent numbers. If we start here, it would be 1, 3, and 4. So the lowest numbers we can give things is to go 1, 2, 3, 4, 5, 6. And I would just make a list because sometimes we lose track of things. So in number 1 here, we have a propyl. Number 2, we have a methyl. Number 4, we have an ethyl. And our parent is cyclohexane. So you alphabetize according to E, M, P. So we're going to cite ethyl first. 4 ethyl, 2 methyl, 1 propyl, cyclohexane. So down below here, I just encourage you to pause the video, write the names below each of these structures, and then push play and I will go over them with you. So the first one, our parent is going to be cyclopentane. We have 2 substituents on the ring, so the numbers are assigned alphabetically, whichever alphabetically comes first. So we have an ethyl up here. We have a methyl down here. So this will be 1 and 2. So we're going to have 1 ethyl, 2 methyl, and our parent is cyclopentane. The next one, this chain is 3. This chain is 1, 2, 3, 4, 5, 6. So that's our parent chain. We want to give our substituent the lowest possible number, so we're going to start on the right side. So on number 2, we have a cyclopropyl group, and our parent chain is hexane. Letter C, we have 4 in the group of the ring. We have 2 outside. So this will be our parent. we're going to give since we only have one substituent, we don't have to give it a number, so we'll just call it ethyl cyclobutane. If you want to call it 1-ethyl cyclobutane, that's okay. Letter D puts everything together. So we got branched groups and 2 things on the ring. Our parent chain is going to be cyclohexane. The group up top is ethyl. The group below has 2 names. You can either call it isobutyl, or you could call it 1, 2, 3. You could call it 2-methyl propyl. So if we put this together, first let's use these, I'll highlight them. First let's use ethyl and isobutyl. So when we would put this together, ethyl comes alphabetically first. So we're going to call this number 1. Remember, we don't ignore iso. We alphabetize according to it. So this would be 3-isobutyl. So we'd have 1-ethyl, 3-isobutyl. Parent chain is cyclohexane. Or if we use the lower name here, we'd alphabetize according to M. So it'd still be 3 here. You could call it 1-ethyl, 3-2-methyl propyl, cyclohexane. As you can see, the names are starting to get pretty long. The next one, our parent chain, is again cyclohexane. We want to give everything the lowest possible number. So we're going to number this way, 1, 2, 3, 4. So we have a 1,2-dimethyl. It'll be alphabetized according to M. We have a 4-ethyl. It'll be alphabetized according to E. And our parent is cyclohexane. So we'll put this all together. We get 1,2-dimethyl, 4-ethyl, cyclohexane. And last one, our parent chain is cyclohexane. That's the longest chain of carbons we have. Over here, we can call this group here isopropyl, or we can number it as a subparent and call it 1-methyl ethyl. Above, we can use sec-butyl for that group because it's a secondary carbon, or we can call it 1, 2, 3, 1-methyl propyl. So let's put it all together. So let's use these top names first. So we alphabetize according to B in sec-butyl, I in isopropyl. It's one of those weird exceptions. So our sec-butyl is going to be number 1. Our isopropyl is going to be number 3. So we get 1 sec-butyl, 3 isopropyl, and our parent chain will be cyclohexane. Using the bottom names, we alphabetize according to M versus M. They're the same all the way out to this E versus P. So we'll call this 1 and this 3. So they reversed in this case. So you get 1,1-methyl ethyl, 3,1-methyl propyl, and then cyclohexane. And again, either of those names is correct.